This episode is sponsored by Linode. Linode is offering listeners of this podcast a $20 credit, which is good for 4 free months at their lowest plan. Their plans start at 1 gigabyte of RAM for $5 a month. You can get your servers in any of their 10 data centers, and their high memory plans start at 16 gigabytes. Get a server running in under a minute. They do hourly billing with a monthly cap on all plans and add-on services like backups, node balancers, Longview, etc. VMs for full control, running Docker containers, encrypted disks, VPNs, etc. You can run a private Git server. They provide native SSD storage, 200 gigabit network, and Intel E5 processors. They have 24/7 friendly support, even on holidays, and a 7-day money-back guaranteed. So go check them out at linode.com/JavaScriptJabber. Hey everybody, and welcome to another episode of JavaScript Jabber. This week on our panel we have AJ O'Neill.
Yo, coming at you live from Provo, Utah.
Aimee Knight.
Hello from Nashville, Tennessee.
I'm Charles Max Wood from devchat.tv. I'm just going to do a quick shout out about the course I'm putting together about finding a programming job. I get asked about that a lot, so definitely check that out. More information on devchat.tv. We have a special guest this week, and that is Ari Lerner.
Hello from sunny Phoenix, Arizona.
Nice. Now, do you want to just remind people who you are real quick? We haven't had you on for a little while.
Yeah, it has been a little while. Sure. I am Ari Lerner. I'm the author of NG Book, Full Stack React, and a couple other books. I also co-run a website called newline.co. Newline.co teaches all about the blockchain and Ethereum and smart contracts and a bunch of other things.
Wow.
I have not heard of that yet. I'm going to have to check it out.
Yeah, it's pretty rad.
So I'm curious, you go from Angular to React to blockchain. Is the framework war all in your head then?
Yes. We also have a book, machine learning book coming out in 2 weeks that I help co-author, and we have another book coming out on Elixir in a couple months, and we have another one coming out on React Native in about a month. Nice. So yes, all the frameworks.
All the hotness.
Yep.
That's right.
So we did bring you on to talk about blockchain. And I know that I've had conversations with AJ about it. I'm still not completely sure I understand it. Do you want to give us kind of the 10,000-foot view on what blockchain is and what people are using it for?
Yeah, totally. So the blockchain is, I think, and we happen to believe that it's Web 3.0. The reason why we think that is because it's the blockchain solves a really interesting problem in the computer science world. That's how do you trust data that comes from untrusted nodes in an untrusted network? Meaning, if you have a bunch of machines that you don't necessarily know who the owners are and you want to have them all networked and participating in a trusted network, the blockchain is one potential solution to that problem. And so the way that it works is basically you use something called a Merkle tree. And do you know what a hash is? If I say what a hash is?
I feel all of us do, but maybe you should back up and also go into that for people who are just getting started.
Yeah, totally. So
traditional computer science defines a hash differently from, the data structure that's like an object in JavaScript and a dictionary and a lot of other languages. So a little clarification there might be good too.
That's a really good point. So a hash, when I talk about a hash from the blockchain perspective, we're not talking about a data structure. We're talking about an algorithm that takes any arbitrary sized input and maps that arbitrary sized amount of data to a fixed size. So when you hear something like MD5 or SHA-256, that's what I'm talking about. So if you've ever used Git, you'll know you get these Git hashes. Those hashes are actually there. I believe in Git it's SHA-256 of the data that's contained in your directory, and it's a unique number that's well, not really a number, it's a gigantic number, but it's a unique fixed value that refers to the data inside of your directory. So if you change anything inside your directory, you add another file, even if it's an empty file, or you change a single character, that hash or that big arbitrary long piece of data is going to change. So you can kind of trust that number is always going to be mapped to the data that you have. One other unique thing about that hash is that it's one-way. It's a one-way hash. So you can't take a hash and decrypt it into all the data that's in your directory if we're talking about Git. So you can only go that one way. And so the blockchain, what it does is you have all these things, you have all this data that you want to transmit. Well, wait, one step back. The blockchain is really just, all it is when we talk about the blockchain is just an ordered ledger. So it basically has, you start with let's say there's 100 coins in your Bitcoin network, and it starts with a name that says 0. It's like the initial amount of coins, so there's 100. And let's say that Bob wants to send some to Alice, and Bob is the only one who has 100. Then Bob sends 10 Bitcoins to Alice. Now there's only one entry in the blockchain. And inside that blockchain, you have a couple different values. The values being what is the hash that we just talked about? What's the hash of the last known transaction? And that last known transaction for the first one is in this example, is the only transaction in there. So you're only going to have one hash. So the blockchain, the idea behind the blockchain is that all the computers in the blockchain have the list of transactions that we just described, and you can trust, and every single node in the blockchain that's participating can trust that is a verified list of transactions. That way you can't fake a transaction being passed from one computer to another computer. So from 10,000 foot view, it's the blockchain refers to a trusted network. And there's a bunch of different types of chains also, of blockchains. There's things like Ethereum, which is really cool. You have the main Bitcoin network. There's a bunch of others. I can't even begin to list them all.
Right. So you have this trusted network, which I'm assuming just consists of a whole bunch of nodes that all have the ledger. And then how do they use the hash?
Right. So if you take, let's talk about an object from a JavaScript perspective. Inside that object, let's say that you have a name of a person that's sending. So we'll say that Bob is sending to Alice. You have the name of the person that's receiving the Bitcoin, that's Alice. Then you have the amount they're sending. And you have things like versions and the size of that object. And you take that object and then you run it through a SHA-256. So from that object, you get this unique value that says this is the data that's in that object. And so you can trust that the data inside that object is the valid amount of data that's in. You have a valid amount of data that's inside that object, and any node can take that hash and can take that object and say, yeah, this is true. This is the data that's inside this object is the data that I expect to receive. So that's one side. The other side, when you're talking about mining, is that the blockchain. What you're trying to do, what every miner is trying to do, is solve this really hard computer science problem, and that computer science problem is basically trying to compute the next lowest hash. And when I say lowest, I mean the smallest amount of value. So way back when Bitcoin started, the first hash had a single 0 in front of it, and that was the lowest. That was the absolute lowest hash available. And so every computer that was participating back then, which was maybe like 3, was trying to find a hash value that was lower than that hash. So something of lesser value, like if you have 100, like a hash that equals 100, we're trying to find a value that's 99 or less.
Mm-hmm. I still don't know if I completely follow, but
diagrams.
How is 0? higher than it anyway.
Oh, sure. So when you have a hash, let's say that we're talking about like a 6-bit string long hash, and you have 0, A, B, C, D, and E. When you're talking about the value of the hash, 0, you can kind of cut off that first 0, so you only have those 5 characters, A, B, C, D, and E. And so basically, that is, if we start that as the first hash value, and because hashes are unguessable, in order to come up with a hash that is instead of 0, A, B, C, D, and E, if you want to come up with a hash that's 0, A, B, C, D, and D, you can't just hash some value. You need to have the exact value that hash, because it's one way.
Oh, right.
You can't just say, oh, that's going to be A, B, C, D, and E, or A, B, C, D, and D. You have to say, well, shoot, what value computes to that hash?
Gotcha.
So the way that you do that in the Bitcoin network or in the blockchain is you use this thing called a nonce. And a nonce is you can think of it as a random value, and that is added to the end or the beginning of that hash, so that when you hash a string, you hash that original object and you say, okay, this object that we were just talking about that contains all these pieces of data, and you add this little string called a nonce, then does that all together equal less than 0, A, B, C, D, and E?
Gotcha.
If it does, that's considered a valid block. And when one machine broadcasts this valid block to the rest of the machines, as long as enough of the rest of the machines accept that as a valid hash, then every single machine has to start over and start with a new hash. And the new hash is the one that's just less than the previous hash. So every single computer will now move on to 0, A, B, C, D, and D.
Gotcha.
Does that make sense?
Yeah, this is really interesting. So, what if two machines get the same or get the same answer relatively close to each other?
Well, you're fighting probability.
Right.
You're fighting probability there. The chance of that is less than lightning striking the same place 3 times. However, if it does happen, it's the rate at which other machines will accept the value as the accepted value is the wild card there.
Okay.
So this is why, and there's lots of interesting things that hackers have tried. Malicious people who are trying to manipulate the blockchain. The easiest way to manipulate the blockchain is have 51% of all the miners. Then you can accept all.
Mm-hmm.
So one of the big fears in the beginning was that maybe China will have 51% of all the machines participating in Bitcoin. If that's true, then China can say, oh, we'll just accept everything that one of our machines computes and nothing else from another machine across the world.
Okay, so you've already answered like a lot of the things that I wanted to go over, like how people are making money using hashing. I wanted to make sure like we went through the difference between like a block and the blockchain itself. I have another question, but I'll save it for later. But my question for right now, if we can kind of change directions just a little bit, can you describe how a transaction works on the blockchain? We've kind of touched on this a little bit, but can you kind of separate this out and go into it in a little bit more detail?
What do you mean when you say transaction?
So like you're talking about maybe before we got on the call, like a lot of times people, when we're thinking about blockchain, they think about Bitcoin or they think about Ethereum, but can you talk about, so, if we're thinking about currency, how does the blockchain work for exchanging currency?
Sure. So the blockchain and Bitcoin are actually two very, very different topics.
Yep.
when we talk about Bitcoin, a lot of times we're talking about the block, or we're talking about the blockchain, and we don't know it. Or if we're talking about the blockchain, a lot of times we kind of like converge on those two things. So the blockchain itself, when we talk about the blockchain, we're simply just talking about that the algorithm, or not really the algorithm, the workflow that I just described, which is like one node can accept a value from another node. When we talk about Bitcoin, Bitcoin is really the creation of value based on speculation. So if you get a $100 bill from your grandma for your birthday, you can trust that that's probably going to buy you 20 coffees, or 15 coffees if you're buying your coffee from Starbucks. And you have this value that you're trusting is going to buy you them, is going to be worth that many coffees. When we talk about the value of currency, if you're going to take that $100 bill and you're going to change that into euros, you're going to get something like 80 euros for that. How many coffees are 80 euros worth? I don't know without looking it up. So you can kind of think of the same thing with Bitcoin. Bitcoin is you have a bunch of speculators that are trusting when they purchase Bitcoin that they're going to know how many coffees they're going to get, or they're going to know how much that Bitcoin is going to be worth when you trade it back to US dollar or the fiat that's in the country of their origin. So when we talk about value, we're talking about basically the trust between speculation and value. So really, like $1 or $100 bill is just a bunch of threads put together in such a way that it's like woven and ink painted on these threads, and you just trust that $100 bill is going to get you 20 coffees for your office. Bitcoin can be seen as the same way, and there's a really great book on this. Let me pull it up. I think it's called The History of Money. I'll find it as we're talking. But so basically, like when you talk about transaction, this is why I asked what you meant when you talk about transaction. Basically, the blockchain itself, when one of those transactions is completed, it's basically a block being submitted to the blockchain to say, hey, everything inside this block is a part of the next transactions that are to be accepted, and that can be one transaction, it can be one like trade of value, or it can be hundreds of trades of value. It's just the data that's contained inside that block is the data that goes into that public ledger. So when you talk about can you trade money, when you talk about like a transaction, if you're trading $100 bills for 100 Bitcoin like 3 years ago or 5 years ago, that transaction would be included in a blockchain. That's why it takes 10 minutes. That's why you can't just use blockchain like it's a credit card, because it takes right now approximately 10 minutes to get a transaction to go through on the Bitcoin network.
So a couple things I've heard. One is that you can like pay a higher transaction fee to get it transacted quicker. Is that true of the Bitcoin blockchain?
So the way that the transaction fees work, so basically every machine that's participating in the blockchain has to have some reason to participate, right? You're not just burning CPU and paying for energy to burn through the CPU and GPU. You need some incentive to participate in the blockchain. And so transaction fees, what you're talking about, is everyone who wants to compute something in the blockchain, or let's just talk about Bitcoin. Everyone who wants to participate in Bitcoin needs some incentive. And so those transaction fees provide that incentive. So the higher transaction fee that you submit, the more incentive machines on the blockchain have to complete your transaction. So if you submit a higher transaction fee, if you offer a higher transaction fee, more machines on the network are more likely to take your transaction over somebody else's.
So another question is, it would seem that the value of Bitcoin should parallel the cost that it creates to mine it. So if it would take me $10,000 worth of GPU capacity on Amazon EC2 in order to get a Bitcoin, it seems that the cost of a Bitcoin should be roughly $10,000. So what's the relationship to the cost of mining and the value that it holds?
Sure, that's a really great question. So if we rewind back to talking about the hashes, we go back to our 0, A, B, C, D, and D. There's only one hash that is that's lower than all of the rest of the hashes, and that's 0, 0, 0, 0, 0. So just in this example. So what that means is there's a diminishing, the further we get along the blockchain, the less likely it is to get a smaller and smaller value of the previous hash. So you have this diminishing resource. So the reason why 3 years ago or 5 years ago it was $10,000 on EC2 is worth more Bitcoin is because you potentially have more opportunity to mine that Bitcoin. But now, because we're so far along, we have until something like, I think it's 2024 is when the estimate of Bitcoin hashes runs out, means that it doesn't matter how much GPU you throw at the problem, you still have approximately the same diminishing percentage chance of mining another Bitcoin. So if you threw $10,000 at EC2 to mine Bitcoin now, it's worth your amount of Bitcoin that you're going to get out of that is going to be worth increasingly less. And the Bitcoin is going to become more increasingly valuable because there are less out there.
Well, right. But what I'm saying is, like, if it took $10 to mine the first Bitcoin, then it would take, say, $12 to mine the second and $14 to mine the third, and so on and so forth. So, if we know what the next coin is to be mined, and like the speculative value, I would imagine would be the value once all of them have been mined. But the value that we see, like, we would see a constant rise in price. I mean, like, because why would I buy a Bitcoin for $6,000 if I could mine two for $3,000, right?
Sure. So you're playing the betting game there, right? So if you're the bet that you would make if you buy, let's say you buy $100 worth of Bitcoin, which is like something like, I don't know, today, like an 8% of a Bitcoin. Let's say that you buy $100 worth of Bitcoin today, and you're making the assumption that the speculative value of everybody around the world is going to want more Bitcoin in the future. So if you buy $100 worth of Bitcoin now, you're betting against the world that you're going to have, that is going to be worth more than you paid for it. The same thing can be said for if you're going to mine it. If you can buy $100 worth of EC2 instances to mine Bitcoin, you're making a bet that those machines are going to be faster than the rest of the machines on the network, and you're going to actually mine. The computers that you purchase are going to be the ones that actually mine the Bitcoin off the network.
Well, I mean, like, I'm not saying a specific dollar amount. I mean, there's a point at which it's not a bet. There's a point at which, like, you spend enough money, you have enough CPU power, you will get the coin.
Which is everything. That's not true. Every single CPU, every single GPU on the network has approximately the same chance of mining the next block. So it's just like if you buy 10,000 lottery tickets and you don't win anything because the person who bought one lottery ticket wins the entire jackpot. So you're making a bet when you buy a lottery ticket that your single ticket or your 10,000 tickets are going to be the one that actually comes up with the jackpot value number or the jackpot value. Does that make sense? So, like, because all you're doing when you're in Bitcoin is you're you're basically just randomly guessing and hashing and running a value through a hash function and guessing at the next lowest hash. Doesn't matter how much GPU or CPU processing power you have. It just matters that the nonce that you're guessing at is the right nonce. So you could buy 10,000 machines on Amazon EC2 and still not mine a Bitcoin.
This is also interesting. I'm curious.
Just so I don't forget, the name of that book is called The History of Money from Ancient Times to the Present Day. It's fantastic. I highly recommend it.
Awesome. What I'm curious about, I know we have a limited amount of time, is you said this is going to be Web 3.0.
Yes.
Why? How? I mean, you know, when I think of blockchain, I'm thinking, you know, Bitcoin money kind of thing, where, you know, it's working like that. But how does this translate to web technology?
Sure. That's a really good question. So when you think about Bitcoin, we're only talking about value. We're only talking about like dollar amounts. But when you think about the blockchain, basically you're reinventing what it is to be a computer. So this is kind of one of the things that Ethereum comes up with, or that Ethereum helps solve. You can imagine if just for a second, the blockchain isn't about transacting money, but it's just about making computations. So let's say that you wanted to, for instance, if you had a public company and you want to allow everyone who owns a piece of that company to make a vote, or shoot, we'll even go further away from companies. Let's just talk about governance elections. Again, I'll answer the web question in just a second, but let's say that the United States wants to provide a true and trusted way to vote for the president of the United States. One way that you could do that is you can create this public list of everybody who's voted, or everybody's votes, and you can trust, provided if you're on a blockchain, you can trust that all those votes that were cast for one presidential presidential candidate versus another one, you can trust that those have not been tampered with. So you don't have like a malicious party. There's no malicious party that's trying to invade or change somebody's vote versus another person's vote. You can trust that. So the reason why, so the blockchain, before I answer the web part, the blockchain itself is the thing that allows us to trust that the thing that we're looking at is true. The thing in this case, in this example, being voting for a president. This is why you can use it for money. So why do I think this is going to be Web 3.0? Because the blockchain allows anybody to participate, which means you can have not just computers, not just servers, you can have phones, you can have Raspberry Pis, you can have printers participating in this network, which basically means you have the entire world scale of computational power at the tips of your fingertips. So when we talk about using the blockchain for doing something at the edge of the network, the speed at which data gets to your phone can be near instantaneous versus the speed that we have now, which is you still have to go over wires, and in some cases you have to go over satellites, and you have to go over network landlines and copper wire telephone lines. So I personally think that having all this computational power at the edge of the network is the thing that makes it so powerful.
As a developer, you love building things that are fun and that matter. Do you want to add authentication to yet another app? Do you want to stay updated with all the security issues and patch them? Why not leave it to the experts? Auth0 is the easiest and fastest way to implement real-world authentication and authorization architectures into your apps and APIs. Allow your users to log in with either regular username and password, social identity providers like Facebook and Twitter, enterprise identity providers such as Active Directory, Office 365, etc., or without passwords with an email login like Slack or phone login like WhatsApp. Getting started is easy. Add authentication to your JavaScript frontend, React, Angular, Vue, and others, or Node.js API in less than 10 minutes by writing only a few lines of code. No credit card required. Get the free plan or try the enterprise plan for 21 days at auth0.io/JSJabber. That's auth0 with the 0. Auth0 is trusted by developers at Atlassian, Mozilla, Bluetooth, Optimizely, Financial Times, and the Wall Street Journal. Try it out at auth0.io/JSJabber. That's auth0 with the number 0, and get back time building core features. AJ brought up a good point in the chat. He said, well, how would you keep anonymity on your vote if it's all public? And similar with, network traffic and all of this stuff, right? I mean, some of the stuff, if I'm sending pictures of my kids to my wife or something like that, maybe I want it public, maybe I don't. But if it's all part of the ledger of transactions or something like that, then how does that work?
Sure. So everything on the blockchain is public. That's the first thing to know. Everything that is submitted there is a public value. And you can have, if you want your name anonymized, you rather than tying your name inside the blockchain, you can tie it to some cryptographic value. So that's why Bitcoin is faceless. That's why you don't necessarily have identity tied to the purchases, is because you have this cryptographic value that represents the thing that you specifically own. So if we are talking about like publicly voting and you don't want your name publicly voted, or your name out there for who you voted on or what you voted on, you take a cryptographic key and you say, this is my key and you're the only one that can prove it. And that's just using basic cryptography.
But then how could you verify that one person didn't vote 6,000 times by creating 6,000 key pairs?
So that would be an implementation detail of how you create the voting. So if you create 6,000 wallets, those 6,000 wallets are going to be tied to 6,000 different people or one different person. So if you wanted to create a voting system, for example, this is somewhat of a rough example, but one way you do that is you could create a centralized server where you have to log in with your own cryptographic hash that ties you to some specific piece of data. So your cryptographic hash, your key, your cipher could be something like your name and your date of birth.
And then like with blockchains, so one of the things I finally got my Bitcoin off of Coinbase because of the split that was coming up. Somebody that was really into Bitcoin said I'd be much better off if I transfer my money before any splits, because then if there's a benefit, then I have control of like buying and selling on my own, and I don't have to, wait for whoever's in charge of it, like Coinbase, telling me whether or not they're going to honor the fork and whatnot. But then I quickly realized that when I share my public ID with someone, in that very moment, they can see my balance. So if I wanted to use it for a purchase and not just like a stock type of thing, somebody would see my balance. They would see every transaction I've ever had, and they'd see every other person that I've ever transacted with.
With work, yes.
It's kind of scary.
Kind of. It takes work to do that, though. Like, especially, so one of the cool things about Bitcoin itself is that you can create new addresses just for receiving money and just for sending money. So if you create a receiving address, it's tied. You can think about it as like your sending address plus a little nonce, or let's talk about receiving address because that's the question that you asked. You can create a receiving address, which is like basically your receiving address plus a little nonce. So when somebody submits a transaction to that wallet, that's tied cryptographically to your actual address, but it's a completely different address. So it does take work. It'll take work, kind of a lot of work, to trace every single transaction and your balance out. In addition, when you talk, one of the troubles, or one of the drawbacks to using Bitcoin itself is it's hard to get your current value, because you have to run through every single one of the hashes. You have to run through all the addresses, and you have to compute just for the addresses that you know belong to you, both your withdrawals and your deposits. So it's not like you can look at the blockchain and say, oh, my balance is 100 Bitcoin right now. You have to go through and actually compute all the different hashes. And I think right now it's like at 42 gigs of data, which is what the blockchain is, might be a little bit more. So you have to run through all that data to even find out your current Bitcoin value.
Well, but like blockchain.org keeps the list that's at the top, right? So because otherwise I wouldn't be able to prove to you that I have any value, because you'd have to download 42 gigs to know that I had $10.
Yes, so that's why services like Bitcoin.org or Coinbase work. That's what they do, and then you have these what are they called? That's a lot of what these exchanges do. So I wanted to come back and answer another part of the web question before we move on, if you don't mind.
Yeah, absolutely.
I'd love to hear it.
So things that you can do on the web, if you have these like little pieces of computation that are being fired on the network, networks like Ethereum will fire off events. So you can listen for these events to get fired off on your web page, right? So like if we think about chat, if you have a blockchain that's specifically chat, it's just your chat history. Every single time that you get a new chat message, every single time that a new chat message is accepted in the blockchain, you can listen for that on your web page, and you can have this public chat that's verifiable and true. You know that somebody is chatting. So you have, not only can you listen for these events, but you can also submit directly through JavaScript events to be computed in the network as well. So you're not just limited to money. You're also, you can think about it just like it's like a pub sub. Like it's a gigantic global pub sub machine.
That's interesting. I could also see it for something like Google Doc. So
yeah,
every time
totally.
Somebody submits a new change to the Google Doc.
Totally. One of the courses that we're working on right now for newline.co is how do you make a distributed Airbnb. I believe we're also, one of the ones that we're working on kind of a little passively for further in the future is a distributed TaskRabbit.
So you guys are kind of getting into the one more thing that I wanted to talk about, which we kind of talked about, but was just to get into maybe more detail, because I feel like everybody just automatically thinks of like Ethereum and Bitcoin with blockchain, but they don't necessarily think about all the other like implementations that you can use that it can be applied to. So like we're talking about like Airbnb and stuff like that. Do you maybe want to go into maybe some other things where people are using it?
Yeah, there's tons.
Yeah. I've heard about it like really disrupting like the music industry and stuff like that, because people can go to each other instead of going through like a third party.
Yeah, so that's a really good, I'm glad you brought that up. There's a ton of different things that people are using it for. For instance, one of the really popular blockchain quote unquote disruptors is like building a distributed Uber. I believe
that
was.
I've heard that too. Yep.
Yeah. So you have like, you don't have Uber taking any of your money. You have, simply the network taking your money. There's also other ones like can't think of the name of the company that is doing it right now off the top of my head, but there's one that does, which is super cool. It ties your identity to the blockchain. So
that sounds really scary.
well, you can think about it. So basically, the way that this one works, I think this is super cool. But it's me. I think it's super cool where you can basically take like a public key, and for any machine that you're trying to sign into, as long as you have that public key on your machine, you have the ability to, or you can log in without a password. So as long as you have that key, every machine that you try to log into, you don't need to remember any passwords anymore. I think it's super neat. There's other ones. I think one is called Golem, if I remember correctly, where it's like that's the global supercomputer. So if you remember, like one of the things that I get really excited about is doing like distributed rendering for something like Maya, which is a 3D rendering program. So imagine if you're making like the next Pixar movie and you want to render all your pixels right now, like either right now you have to spend a whole bunch of money to build a rendering farm, or you have to get a super fast computer and you have to spend a bunch of money. But imagine if you could just participate in a global supercomputer network, then you can get your rendering done like near instantaneously. That would be totally awesome. Other things like doing what is that? What's that called when you like you're trying to solve the DNA chain? Another one of those days where you're trying to like break down how DNA is.
Just gene mapping? I don't know.
Yeah, thank you. Like the genome, mapping the genome. Like that's another open possibility for having a global supercomputer. I told you, like, you know, we're working on a distributed Airbnb as an example of things that you can do with it. So basically, you're taking the middleman out. You're taking like you don't need a centralized server that can be broken into and hacked. You're taking that responsibility outside. You're taking like the computational power that you need of centralized server right now, and you're pushing it to a global network. So another thing is like hosting. Imagine if you could just have all your web apps hosted in a completely decentralized way. There is a company doing something like that called SIA, SIA.tech, that's doing something like that, where you deploy your application into their network and you get this highly redundant, cryptographically secure application hosted completely around the world, which is much closer to the edge. Should be much closer to the edge than even Amazon EC2.
Yeah, that's interesting. So what should JavaScript developers or web developers be doing now to prepare for this world that you're envisioning?
If I had all the answers to that, I probably would be doing it. The best thing that I can say right now is go sign up at newline.tech. We have a bunch of, or newline.co. We have a bunch of free videos as well as paid videos for members on how to learn this stuff. If you don't want to do that, definitely check out the free videos at least. We work really hard to make them the best. You can go, if you go to Ethereum, I think is probably like the leading edge right now. If you want to learn about the blockchain, Ethereum, the homepage has fantastic tutorials and fantastic documentation. I highly recommend starting out there. If I can recommend anything other than Newline, there's one more chain that I think is really super interesting. That is being published in the next few months by the guy who created BitTorrent, called Chia, chia.tech. But it's basically that's it's a different type of blockchain rather than using CPU or GPU power. It's using disk. Now, I can't claim to understand it that well. I've only read through the beginning part of the white paper. It's super dense, but I think that's going to be the next kind of big revolution because it uses proof of storage instead of proof of work, which is green as opposed to needing to chew through a bunch of power. The other thing that I would recommend also, if you're really interested in the answer to Aimee's question, you go to coinmarketcap.com. It's coinmarketcap.com. It lists a whole bunch of coins. I don't know how many it lists, but it lists that those are all the different types of coins that people are using the blockchain for.
It brings me to like a whole another question, but that's for another episode.
What should you invest in? Like I said, I wish
there's so many. And it's just like a free-for-all out there almost right now.
It is kind of the Wild West. And so one of the things that I definitely recommend right now for this is my secret to you, my friends. Definitely I recommend getting involved in it earlier rather than later the right now we don't, at least in the US, we don't have a ton of regulation on Bitcoin.
That's a good point.
And if you get the sooner you get involved, the less chance you have to be regulated. No, I didn't actually say that on a public program, did I? It's not necessarily that I'm like suggesting that you avoid regulation. It's more that the earlier you get in, the more likely it is that you'll succeed.
Yeah, I mean, there's all kinds of things that you can speculate about there, and we just don't have time to dig into it.
No, I wish I didn't open that can of worms. Actually,
no, it's interesting though. I mean, we're talking about getting in now versus later, and you bring up regulation, and will the regulation affect the value of the coin, and that goes into a whole nother.
There's all sorts of things that I can't answer. Yeah, that nobody has the answer to yet. There.
Yeah, but definitely interesting stuff.
One, if you're looking for like a sample app to build, one of the ones that I think that really helped me understand it was building a message board. And you can do that there's a package called, I believe it's just called Web 3.0 or 3.0. Yeah, Web 3.0. That helped me understand how to build smart contracts on Ethereum and build a public message board so I could write the interaction between JavaScript and web page, my web app, and Angular, and the Bitcoin network.
Awesome. Well, I know that some of us have some time constraints, so we're probably going to wrap it up here. If people want to see what you're working on these days, Ari, where do they go?
Newline.co is probably the right answer for that. We're doing a lot of work there. One of the tutorials that we're releasing is how to build your own Bitcoin pay button. So kind of like the JavaScript pay button for Stripe. We're making a tutorial on how to clone that for the blockchain, for the Bitcoin blockchain. And we have a whole bunch of others up there as well. But that's a good spot to see what I'm working on.
All right. Well, let's go ahead and do some picks. Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Aimee, do you want to start us off with picks?
Sure, I can go. So the first one, gosh, I'm sorry about my voice. I keep having to cough and clear it all the time. But the first one, although this is in Python, and this is obviously JavaScript Jabber, it's still good. Like a lot of the stuff we've been talking about is very theoretical, and it's hard to kind of, I don't know, for me at least, it's hard to fully grasp it until I actually see stuff written in code. So this was a really good article. Just giving like some very simple code blocks on like building your own blockchain, but it's called Learn Blockchain by Building One. So that is my first pick, and then the second one, I'm back on like more protein bar kicks. So I was at a CrossFit competition this past weekend, and they had like a bunch of different vendors there selling a bunch of different stuff, and I tried this new protein bar called the Source Bar. And it was amazing. It's like grass-fed whey protein. I don't know. I try to stay away from I've been trying to stay away from Quest bars because they have a lot of sugar, alcohol, and just like a lot of just kind of junk in them. And these seem to be a lot better, and they taste really good. So that's my health pick for this episode. And that's it for me.
Awesome. AJ, what are your picks?
So I'm going to pick for sure spice labels and spice jars, because sometimes you have, as a man that lives singly, just like bags of stuff like chives or whatever because you're lazy and you still wanted to use them, but you didn't bother like putting it in a jar after you bought it in bulk. But it turns out not only does it make for a happy wife, it also makes for a happy life to have labeled spice jars. So I'm going to link those on Amazon and totally recommend that you get some. If you have, like, if you go to the Asian store and you buy the big bag of cinnamon that's going to last you for the rest of your life and only last you $2, and you get like the other things there at the Asian store too, you know what I'm talking about if you know what I'm talking about. If you don't know what I'm talking about, watch for your spices. But go ahead, get the jars and the labels, and then go to the Asian store. It's going to be great. Just trust me. Number two, I'm going to pick, well, you know what? I'm going to pick marriage because I got married recently, and this is what I have to say about marriage. I view marriage as a lifelong commitment, and knowing that kind of changed, it changed the dynamic of the relationship in a good way, to be married. We both have that point of view because, like, if something comes up, there's not like this, I don't know, the fear or the tension or the like, how's this going to affect me? Like, whatever happens, we kind of have that attitude of, we'll figure it out. We're committed to each other. And I like that. I like that solidity that's never been there in any other form of relationship that I've had. And it just makes me feel good. And I like it. And I think if other people, if you have not embarked on that and you decide to, you might like that if you have that mentality.
All right. Well, I'm going to jump in here with a few picks. Now, next week, I am going to New York City, this time without AJ. I'm going to one of the Microsoft things without him. And I am so excited for a lot of this stuff. I'm actually talking to our Microsoft contact right after this call, and I'll say hi for you, AJ. But anyway, I mean, New York City's just a great town. It's a great city. And we're releasing these pretty much the week after we record them. So when this comes out, you all can you can actually see me. I'm going to be pulling together a meetup. We're going to meet Friday evening at the Sheraton Tribeca. So anyway,
Be careful down there.
What was that?
It said be careful down there.
I know, right?
That's just where the shooting happened.
Oh, it is?
Yeah.
Oh. Anyway, sad stuff. But anyway, so I'll be at the Sheraton Tribeca Friday night. If you go to devchat.tv/events, it should show up there, and I should have the meetup details. Anyway, we'll just see whoever's in the lobby at like 7 o'clock, and then we'll go find some food. So if you want to come and you're in the New York City area, then definitely check that out. If you have some recommendations of places to eat or things to see, that would also be cool. I did some sightseeing last time, so some of the big things I've already seen. But anyway, I'm just looking forward to experiencing it again. And and then my wife and I have started watching Stranger Things Season 2, and so far it's pretty darn good. So I'm going to pick that as well. Ari, what are your picks?
Yes.
Well, in reverse order, instead of starting out with something computery or technical, I am actually moving to New York City on December 1st. So if you're in the New York City area and you want to hang out or you want to do some interesting things, let me know. Hit me up. I'm at a user pretty much everywhere on Twitter, GitHub, Instagram. Just look up a user. That's AUSER, and you'll probably find me. The other technical thing that I wanted to mention was that Aimee referenced learn blockchains by building one. It's in Python. I highly recommend taking that tutorial and trying to build it in JavaScript. It's a really good tutorial in Python, and it's a really good exercise to build in JavaScript if you're a JavaScript developer.
Very cool. I'll have to check it out.
Cool.
All right. Well, do you want to tell us one more time the name of your company? Because I just can't remember it. And then.
Oh, sure. My company is FullStack.io, but our website is newline.co.
Newline.co.
Yep.
All right, folks. Definitely go check that out if you want to learn more. And thank you for coming, Ari.
Yeah, thanks for having me. This is fun.
All right. Well, we'll wrap this one up, and we will catch you all in a week. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.